16. Okay. So we are discussing about the column which is having a biaxial bending. Biaxial bending indicates the column which will be bending in two direction. Okay. So straightly we can start now. Okay. So നമ്മള് നേരത്തെക്കാളും ഒരു reverse order. We are following a reverse order over here. So till where we have find out. We have find out. Okay, we have assumed the percentage of reinforcement ratio. With the assumed the percentage of reinforcement ratio, we have find out mu x1 and mu y1, that is moment capacity along the x direction and moment capacity along the y direction. Okay, so you run the quantity we have find out. Next is you have to find out puz. Next step is you have to find out puz. Okay, so what is puz? Puz is the ultimate load carrying capacity of the column. Okay, puz is the ultimate load carrying capacity of the column. Okay, so how will you find out it? The ultimate load carrying capacity of the column can validate. You can refer. Okay, so there is one equation. Okay, there is one equation, that is pu set. Okay, that is you can refer is code now. Okay, so take sp16 chart 63. Okay, take sp16 chart 63 la. Okay, see sp16 chart 63, page number 148. Okay, ഈ ഒരു ചാർട്ട് വെച്ചിട്ട് you should find out PUZ. So PUZ എന്ന് വെച്ചാൽ PUZ is the ultimate load carrying capacity of the column. Okay, so here you can see the top portion. Okay, on the top portion this is a reinforcement percentage. Okay, reinforcement percentage ഉദ്ദേശിക്കുന്നത് എന്താണ്? Percentage of reinforcement ratio. That means P. Okay, so this indicates P, percentage of reinforcement ratio ആണ് ഇതിരിക്കുന്നത്. Okay, reinforcement percentage. Okay, that means നമ്മൾ how will you represent P, reinforcement percentage? P ആയിട്ട്. Okay, so this is the non quantity, so we can start from here. So P we have assumed it as how much it has. We have assumed percentage of reinforcement ratio as 1.2 percentage. Okay, so take 1.2 over here. Okay, so this chart, how to take this chart I will show you. First of all, see this. Okay, so this is, okay, so this is 1 and this is 2. Okay, so this is 0.2 division. Okay, the one, this will be 1.2, 1.4, 1.6, 1.8, 1 then 2. Okay, so that means ഒരു 0.2 ആണ് അതിൻ്റെ each division. So this is 1.2. Okay, so this is 1.2. Okay, now 1.2 nulla point you have to extend till Fe 415. So our grade of steel is Fe 415. Here you can see these three lines indicates the grade of steel. So this is 250, 415 and 500. Okay, so ours is 450. Okay, so extend the line to Fe 450. Okay, Fe 415. Now drop it down till it meet the point of our grade of steel. Our grade of steel എത്രയാണ് 20 ആണ്, M20. We are using M20 grade. Okay, so we are using M20 concrete. Okay, so drop this point to M20. M20 എന്ന് പറയുമ്പോൾ this is M20 grade of concrete. So drop it down. Okay, so this is M20 grade of concrete. Now go to the x-axis. Now go to the x-axis. So this is the point that we have to find out. Okay, so this is the point. ഈ point എന്ന് വെച്ചാൽ എന്താണ്? P user divided by AG value ആണ്. Okay, so you have to find out this point. Okay, so this point here 10 ആണ്, 15 ആണ്. Okay, so uh, so this is 11. This is one division. So 11, 12, 13, 14, 15 ആണ് വരുന്നത്. Okay, so this is 11, 12. In between 12 ഉം 13 ഇടയ്ക്കാണ് the point has come. Okay, the point is between 12 and 13. Okay, so we can take this point as 12.5. Okay, so we can take from the graph PUZ divided by AG is equal to how much we got? 12.5. Okay, so this is how you have to take the value from this graph. Okay, okay, so how will you take other percentage reinforcement ratio? The arrow is indicated here. How to use this graph they have shown you. See, you can see the guidelines. So that means first you have to choose your percentage of reinforcement ratio, choose your grade of steel, drop it down to the grade of concrete, and then go to the y axis. So y axis il either point lano coincide, take that point. Okay, so that point will give you the value of pu by ag. Okay, now we have got that pu by ag is equal to 12.5. Okay, now go to our slide now. Okay, go to our slide. That is pu by ag is equal to puz divided by ag is equal to 12.5. From this we can find out puz is equal to 12.5 into ag. Ag means what? Area of the gross section. Okay, area of the gross section. Gross section is how much it is? 12.5. The dimension of our column is 500 into 600. Okay, okay, మొత్తం gross section of that column. Okay, so 12.5 into 500 into 600. How much you will getting? So you will get it around 3750 kilonewton. Are you getting this? 3750 kilonewton. Okay, you will get the value as 3750 kilonewton. Okay, so now that we have find out the ultimate load carrying capacity of the column. Okay, next is you have to do the check. Next is you have to do the check. Next step is step number 4. I think you have to check for the biaxial bending. Okay, you have to check for the biaxial bending. Okay, no, so this is very simple. Okay, it's not complicated as you think. So there is two types of check. You can do either one. Anyway, I will introduce you to checks. Okay, first check is that mux1 mux divided by mux1 or muy divided by muy1 permissible value should be greater. should be greater than should be greater than the moment mu x divided by mu x1 or mu y divided by mu y1. Okay, ഫസ്റ്റ് ചെക്ക് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ mu x divided by mu x1 permissible അല്ലെങ്കിൽ mu y divided by mu y1 permissible should be the greater value when you compared with the mu x divided by mu x1 or mu y divided by mu y1. Okay, so this is the value you are getting from is code. Okay, so this is the value you are getting from is code. Okay, so is code refer ചെയ്യുന്ന value should be greater than the moment ratio that is developing in the column. Okay, so how to refer the value, that's the next thing. Okay, so first of all, let's see how to find out the value. Okay, we'll find out the permissible value. Okay, so for that again we have to refer SP16 chart 64. Okay, for that you can refer SP16 chart 64, and you also needed one ratio, that is the ratio between PU and PUZ. Okay, ratio between PU and PUZ. Okay, so PU is how much? 2000 kilonewton, right? 2000 kilonewton divided by 3750. So approximately you will get this value as 0.53. Okay, 0.53. Next is mu x divided by mu x1 and mu y divided by, okay, first of all you will take mu y divided by mu y1. Okay, so tell me the value, how much you're getting? Mu x divided by mu y1, how much you're getting? Mu x means moment that is developed in the column, so that is 150 kilonewton. 150 kilonewton, and moment developed mu x1 etra? Tell me fast. I think 324, something like that. So here mu y is equal to 120 kilonewton. So tell me how much is the value? Mu x1 is etra varna? Okay, 324. And how much is mu y1? How much is mu y1 fast? 270. Okay, so mu x എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ moment that is given in the question. Okay, mu x1 is moment capacity. So how much is the ratio? 150 divided by 324. You will get it as 0.46. And 120 divided by 270, you will get the value as 0.4. Are you getting this? Okay, you will get the value as 0.4. Okay, now using this value we should find out the permissible value. Okay, so first of all you can choose, there are two values alle, mu x1 ഉണ്ട് mu y1 ഉണ്ട്. You can choose any one of this, ഇതിൽ ഏതെങ്കിലും ഒന്ന് choose ചെയ്യാം. Okay, so for now we can take this value mu y divided by mu y1 ഉം പിന്നെ pu divided by puz. Okay, using these two values we can find out the permissible value for mu x divided by mu x1. Okay, now take the chart. Take the chart of SP16. Okay, so chart that is just below, that is chart 64. Take the chart 64. So in this you can see chart 64 la, you see the curve that indicates pu divided by puz values. Okay, y axis you can see mu y divided by mu y1 x-axis you can see MUX divided by MUY1. Okay, so from this chart you should find out MUX divided by MUY1 value. Okay, so let's start doing. So PU divided by PUZ value, how much we got? 0.53. Okay, so this chart is, this is 0.4, 0.5, this is 0.6. Okay, so 0.53 the curve will be somewhat like this. Yes, curve will be somewhat going like this, 0.53 curve. MUY1 value, how much we got? We got it as 0.4. Okay, so 0.4 directly we are having here. Okay, 0.4 directly we are having here. So drop the line. 0.44 ഇങ്ങനെ വരക്കുക. 14444.4. Here it will intersect. Somewhat here it will be intersecting. Drop it down. Drop it down to somewhere. Okay. So this point is your MUX divided by MUX1 permissible as per the IS code. Okay, are you getting this? We are going to find out the permissible value for MUX and MUY. MUX divided by MUX1. Okay, first you should know PU divided by PZ ratio. A ratio എടുത്തു. Okay, then we also need to know one more parameter, that is MUY divided by MUY1. Okay, so MUY divided by MUY1 is 0.4. Draw a line to the curve, drop it down. Okay, so here it is intersecting at this point. ഈ പോയിന്റിലാണ് ഇന്റർസെക്ട് ചെയ്തിട്ടുള്ളത്. ഓക്കെ, സോ MUX divided by MUX1 പെർമിസിബിൾ വാല്യൂ ആണ് നമുക്ക് ഇപ്പൊ കിട്ടിയിട്ടുള്ളത്. ഓക്കെ, സോ ദിസ് വിൽ ബി അറൌണ്ട് 0.85. Okay, so this is 0.8 to 0.9. Okay, so that value will be 0.85. Okay, so write down the permissible value. Okay, that is from the from the SP16 chart 64. Okay, so from the SP16 chart 64 la MUX divided by MUX1 permissible value is 0.85. Okay, so what is the real value? MUX divided by MUX1. So that is, we got it something like 0.46, right? That is 150 divided by 324, right? How much you got? 324. Okay, so that is around 0.46, something like that. Okay, somewhat like 0.4. Okay, so the condition is satisfied. The permissible value is highest. As per the IS code, the permissible value should be highest. That is MUX1 permissible is greater than MUX divided by MUX1. So which means your design is safe. Which means your design is safe. Okay, so this is, okay, this is one check. Okay, now next is another check, the most important check. Okay, so this check is mandatory check for biaxial. Another check, this is very important check. Okay, you can, if you want, you can skip the previous check, but this check you cannot skip. The check is MUX divided by MUX1 all raised to alpha n plus MUY divided by MUY1 should be less than 1. Okay, so this condition has to be satisfied. So this is the most important check for the biaxial bedding. Okay, if this condition is not satisfying, you have to redesign the section. Whatever we have assumed, the reinforcement ratio is wrong. You have to redesign. Okay, so this condition has to be satisfied. Okay, so already we know what is MUX and MUX1. MUX means how much? 150, 324. Already all this value we know. We need to know the value of alpha n. Okay, you need to know the value of alpha n. Okay, so let's find out the value of alpha n. Okay, so for the alpha this value, you can refer the IS code. So IS code la, either this is also in page number 71. Okay, IS code page number 71 la, this is available. If you go for IS code page number 71 la, see the page number 71. Okay, page number 71 la, you can see this. Close 39.6. Okay, close 39.6. Page number 7 close 39 point. They have members subjected to combined axial and biaxial bending. Okay, so this condition has to be satisfied. MUX divided by MUX1 plus MUY divided by MUY1 all raised to alpha n should be less than 1. Okay, so all the values we know. Okay, alpha n the alpha n. Okay, so alpha to PU divided by PU. Find value get from the PU divided by PU Z ratio. So PU Z is 0.4 FCK into AC plus 0.75 because we have already find out PU Z from the chart. If you are not using the chart, you can use this equation. Okay, a chart to make in the equation either okay. So let's see PU by PZ ratio 0.2 to 0.8. Alpha n is for the values of PU divided by PUs are ranging between 0.2 and 0.8. The values of alpha n varies linearly from 1 to 2 and values less than 0.2 angle alpha n is 1 and for the values greater than 0.8 is alpha n is 2. Okay, so from this range you have to find out the value. Okay, so this is also available. Okay, page number 104. Okay, page number 104. This is available. Clause 33.3. Member subjected to biaxial bending. Okay. So here also they have mentioned the same thing. Okay, he condition PU set value either you can follow this equation or you can use chart 63. Here it is given. Okay, the chart 63 can be used for evaluating PU set. Okay, so anyway we have find out using chart 63. Forget it. You have to find out alpha and value. Okay, so from this what they are telling is that okay, if PU divided by PU set value, if it is less than 0.2, okay, if it is less than 0.2 ആണെന്നുണ്ടെങ്കിൽ alpha n value is 1. Okay, if PU divided by PU set value is greater than 0.8 ആണെന്നുണ്ടെങ്കിൽ alpha n value is 2. In between 0.2 to 0.8 നടക്കാണ് വാല്യൂ വരുന്നുണ്ടെങ്കിൽ you have to interpolate and find out the value. Okay, that means see this 0.2 1 0.8 2. Okay, so this is PU divided by PU set and this is alpha n value. അതായത് PU divided by PU set value 0.2 നേക്കാളും ചെറുതാണെന്നുണ്ടെങ്കിൽ alpha n will be always 1. PU divided by PU set value greater than 0.8 ആണെന്നുണ്ടെങ്കിൽ alpha n value will be 2. PU divided by PU set values between 0.2 to 0.8 ആണെന്നുണ്ടെങ്കിൽ you have to interpolate the alpha n values and find out the corresponding value. So here PU divided by PU set is 0.53. So 0.53. Somewhere here you can mark. You have to interpolate and find out this value. Okay, so this will be your alpha n value. Okay, this will be your alpha n value for the problem. Are you getting confused? I am. Okay, so interpolate and find out. So how will you interpolate? If you interpolate, you'll get the value as alpha n value through the using the similar triangle properties. 1.2 divided by 0.6. Okay, you can take this portion as x. X divided by 0.33. So you will get the x 0.66, so which means the alpha n value will be 1.86. Are you getting this? By interpolation, find out the value. Okay. From the by interpolation, find out the value. Now, can we substitute? Confused are you? Are you confused? Just please respond. Are you confused? I'm not understanding what is your reaction. Okay, Anna. Shall we proceed? Okay. For alpha n value, from this interpolation, we got the alpha n value as 1.86. Now, proceed. Substitute in this equation. Okay. Mux divided by mux1 all raised to alpha n plus muy divided by muy1 all raised to alpha n value should be less than mux that is 150 divided by 324 all raised to alpha n is 1.86 plus muy is 200 divided by muy1, how much it is? 270. 270 all raised to 1.86. Okay, how much you're getting? This value should be less than 1. So tell me whether it is less than 1 or not. So this will be 0.23 and 200 divided by 270 all raised to 1.86. So this will be 0.57. So that is equal to how much? 0.57 0.57 plus 0.23. We got the value as 0.8. So which means okay 0.8 already indicated 0.8 upon that is less than 1, which means this is safe in biaxial bending. Namada column is safe in biaxial bending. Okay, so this check is very important. Previous check chart 64 check. If you want you can skip, but this step you cannot skip. Okay, അത് ടൈം കിട്ടുകയാണെങ്കിൽ നിങ്ങൾ ആ ചെക്കും കൂടെ ചെയ്തോ, പക്ഷെ ഈ സ്റ്റെപ്പ് മാൻഡേറ്ററി ആയിട്ട് ചെയ്തിരിക്കണം. Okay, so this check indicates whether the column is safe in biaxial bending or not. So our column is very safe in biaxial bending. Now we can proceed. Okay, so shall we proceed now? Now we can proceed. So now we can calculate AC, area of steel. So how much is the AC? So AC equation as per the chart it is PBD divided by how much? 100, right? PVD divided by 100. That is the chart nothing the value of AC. Okay. So P is 1.2 percentage. B is how much? 500 into 600 divided by 100. So AC value you will get around 3600 mm square. Okay. So area of steel is 3600 mm square. Now you need to find out the number of bars and diameter of the bar. Number of bars and diameter of the bar you have to find out. Okay. So you can refer again IS code. IS SP16 you can take. Okay. Take SP16. Take the chart 95. Take the chart 95. Okay, from the table 95. Okay, so this is the table 95 now. So the area is 3600 mm square, which means 36 centimeter square. Okay, so the one condition is that you have to provide reinforcement on all the four sides. On all four sides, the chart. Okay, the chart that we have taken, it is having the distribution of bars on all four sides equally. അപ്പോൾ നമ്മൾ 4 സൈഡ്സിലും ഒരേപോലെ കൊടുക്കണം. ഓക്കെ, അപ്പോൾ 4 സൈഡ്സിലും ഒരേപോലെ കൊടുക്കണം എന്ന് പറയുമ്പോൾ മിനിമം there should be how many number of bars? ഓക്കെ, 4 സൈഡിലും ഈക്വൽ ആയിട്ട് കൊടുക്കണമെങ്കിൽ അറ്റ്ലീസ്റ്റ് മിനിമം എത്ര 8 numbers of bar എങ്കിലും വേണം. Okay, so let's find out. So 36 centimeter square, if you take from this chart, so this is here you can see 8 numbers of bars. Okay, 8 numbers of bars. If you're taking 8 numbers of bars, if you're using 22 mm, okay, if you're using 22 diameter bar, 8 numbers at the final, that is only 30.41. Okay, so that is not possible. If you are taking 25 mm dia bars, okay, 25 mm, if you are taking 25 mm dia bars, you will get 39.27. Okay, let's see if there is any other options that we can make use. Okay. Just what about if you are using, okay, if you are using 12, suppose if you are using 12 numbers, normal that can be distributed four sides equally, right? 12 numbers we can 8 കഴിഞ്ഞാൽ അടുത്ത 12 ആണ്. After 8, all four sides equally distribute by the next number is 12. Okay, 12 also you can distribute. So if you take 12 numbers of bar and if you go for a 20 mm diameter bar, 20 mm diameter bar, 12 bars at the total area is 37.69. Okay, so that is somewhat similar. So what we needed is 36 centimeter square. So somewhat 36 in similar item the values. Okay, so here we got it as 37.69 centimeter square. Okay, so that value is okay. Like somewhat we can take this value is okay. Okay, so any other values that you want to suggest? Any other number of bars that if you want to suggest, please suggest right now. 36 similar to that, next to 36 the values the values that is next to 36. Okay, so this is 39. The 39 it's pretty large. Okay, so anyway we are having an option, like we are having a value that is 37.69. I think you can go with 37.69. So if you are having any other similar values, you can choose. Okay, there are the values if you are getting from the chart, you can go for it. Okay, so right now from the chart Okay, so again we can say write down the note from the chart. Okay, so from the table 95 of SP16, we have find out. We have come to we have come to a conclusion that you can provide 12 numbers of 20 diameter bars. 20 diameter bars. Okay, so the area will be something like 37.7 centimeter square. Okay, so which is okay. Now next is lateral ties. Design of lateral ties. You have to provide the lateral ties. Diameter of the lateral tie same. Then it should not be less than, what is the criteria? Tell me the criteria now. The criteria. What is the criteria? It should not be less than 1 by 4th of the diameter of the bars. Next is or 6 mm, whichever is less. So diameter of the bar is how much? 20, right? So 20 by 4 അല്ലെങ്കിൽ 6 mm. So this will be 5 and this will be 6. Okay. So which one you want to provide? Tell me a value. 6 mm. Okay, 5 is not available. 5 is not available. Starting in a 6 mm. Okay. So provide 6 mm diameter bars. That's lateral ties. Next is you have to find out the pitch. Next is you have to find out the pitch. So how will you find out the pitch? Same criteria. There is no difference in the criteria. Highest code you can refer pitch. For that pitch, the condition is that it should not be less than the least lateral dimension. So that will be how much? 500. So that will be 500. And second one, 16 times diameter of the bar and 300 mm. I think it will be best if you go with 300 mm itself. Okay, so you can go with 300 mm. That is provide 6 mm diameter bars at 300 mm center to center. Last step is you can go for the reinforcement details. Okay, last step is you can go for the reinforcement details. Okay, so I think reinforcement details you can draw by yourself. On 4 sides. Okay, so don't get confused. This is pretty confusing. Don't worry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so on all 4 sides, we have equally distributed the bar. Okay, now you have to provide the lateral ties. Okay, so one tie will be like this. Okay, it will be like this. Next is central tie. You have to tie. Okay, ഇത് കുറച്ച് വലുതായതുകൊണ്ട് you have to provide here also one tie. So the reinforcement details will be like this. Okay, reinforcement details will be like this. Okay, okay. So if you do one more problem, it will be easy for us. So next we'll do this. We'll try this problem. You can post your name to mark the attendance. Okay, so biaxial bending is